b1 value that is -3, b2 value that is 1, and b3 value that is 5. Now we'll expand this determinant. Now expanding the determinant, here is the I, here is the 15 minus 1 minus j, then 25 plus 3 plus k and 5 plus 9. Therefore, a plus b cross a minus b equals to 14i minus 28j plus 14k. This is required solution. Example 2. Find unit vector perpendicular to vectors. The vector A given i+j+2k and vector B equals to 2i+2j+3k. Step 1. Comparing vector A i+j+2k with a1i, a2j plus a3k, and comparing vector B 2i+2j+3k with b1i plus b2j plus b3k implies a1 is equal to 1, a2 is equal to 1, and a3 equals to 2, and b1 equals to 2, b2 equals to 2, and b3 equals to 3. Now vector perpendicular to both vector A and vector B, that is nothing but vector perpendicular to both vector A and vector B is nothing but A cross B. So that is a vector C equals to A cross B. We need to find out A cross B. So A cross B equals to, therefore A cross B is equal to determinant of ijk a1, a2, a3, b1, b2, b3, that is equals to ijk. Here we have kept the values of a1, a2, a3, 1, 1, 2, and values of b1, b2, b3, that is 2, 2, 3. Now expanding the determinant, we get here 3 minus 4 minus j and 3 minus 4 plus k, and here is a 2 minus 2. So we get minus I and plus j plus 0k. Whenever the 0k is there, we don't write it. Therefore, A cross B nothing but minus I plus j. Now comparing this with the C1I plus C2j plus C3k, that is a vector perpendicular to both vector A and vector B, nothing but vector C given by A cross B, and we got A cross B equals to minus I plus j. Now we need to find out the magnitude of vector C, because they said to find the vector unit vector in perpendicular to both. Find unit vector perpendicular to vector A and vector B. So step 1, to find now the magnitude of vector C. So magnitude of vector C is nothing but under root of C1 square plus C2 square, that is equals to minus 1 whole square plus 1 square. So that is equals to under root of 1 plus 1 equals to under root of 2. Now unit vector perpendicular to both vector A and vector B, that is nothing but vector C divided by the magnitude of C. So vector C nothing but minus I plus j, and magnitude of vector C nothing but root 2. So this is the vector, unit vector perpendicular to both vector A and vector B. Example 3. In a triangle ABC, coordinates of A given, coordinates of B and coordinates C are given. Find the area of triangle ABC by using vector product. Solution: we draw here rough diagram, and now we select the two sides such that one vertex is common. That is, we now select to vector AB and we find vector AB. That is, the A is common to B as well as the C. So we find vector AB and vector AC, where vector AB equals to and vector AC equals to. To find vector AB and vector AC, we require position vector of A, that is position of vector of A nothing but i+2j+3k, and position vector of point B, that is vector B equals to 2i+3j+k, and position vector of C, that is vector C equals to 3i+4j+5k. To find vector AB, we need to subtract vector B minus A. To find vector AC, that is equals to vector C minus vector A. This is equals to. So we got vector AB equals to i+j-2k and vector AC equals to 2i+2j+2k. So we got vector AB and vector AC. Comparing vector AB with a1i, a2j and a3k, and comparing vector AC with b1i plus b2j plus b3k. Now we need to find AB cross AC, that is equals to determinant of i, j, k, a1, a2, a3, b1, b2, b3. This is equals to I, j, k, and here is 1, 1 minus 2, and here is a 2, 2 and 2, which on expansion of determinant gives, so AB cross AC equals to 6i minus 6j plus 0k. Now area of triangle ABC equals to half into magnitude of AB cross AC, that is half into under root of 6 square plus minus 6 square plus 0 square, which is equals to 6 root 2 upon 2. Here cancellation, that is equals to 3 root 2. Therefore, area of the triangle ABC, area of triangle ABC equals to 3 root 2 square units